All right, do we want to start our
Number 3, yeah. Let's start.
cool? Where are we starting?
Do we need to go over the preparation homework?
Mm-hmm. Just on number 7 there.
Yeah,
Sorry.
I guess they could all be different.
It should be. What did you guys get for the mean of your guys' samples?
Yeah, 44,640.
Rachel?
Ah, I can't open that. My laptop.
I got 46,200.
So yours would appear to be more usual, since it's
Yeah.
right in the middle.
Yeah, mine's dead center on it.
So I put mine slightly unusual because it's outside the mean. Mine's kind of slightly to the left, if you can see that.
Yeah.
Yeah, the numbers I drew were random. I literally, I used that website they gave. They gave me 30, 29, 28, 38.
Yeah, I picked mine off the sheet she gave us. I randomly had some of those ones, so I wonder if there's any difference there, and maybe yours is more realistically random.
Oh, maybe.
This graph illustrates distribution. No, we already make a mark, whatever. It's going to be
Yeah,
different.
right.
Explain why or why not.
Okay.
I guess mine's normal because it's dead center in the top of the bell curve.
I don't know if I used the right terminology. I said slightly unusual because it's outside of the middle a little bit.
Makes sense. Rachel, did you get anything there?
Christine, what? Are you on the preparation?
Say that again.
Which number are you?
7.
The line was breaking, so I wasn't following. Okay. That's the preparation assignment, right?
Yeah, preparation assignment number 7.
No, I didn't get that.
Okay.
Randomly says 5 first.
Cool. All right. Move on to 8.
Have you tried using this thing, the website they gave us, the random.org?
Uh-huh.
I tried to figure out, but still I couldn't understand anything.
Okay. All right, where do we go from here?
We're number 8.
The shape should be normal.
Yep, that's what I got.
And B,
Yeah.
it's gonna, the reasoning why it's gonna have that shape, such a large number.
Normal.
The larger the number is, the smaller your
Sample will be distributed.
and the standard deviation will get smaller.
Mhm.
The bigger the number is, so then you have it'll make more of a bell curve each time.
C is pretty self-explanatory. How did y'all get D?
Standard deviation of the distribution of gains. They're small because under the law of large numbers,
This is what is the standard deviation for D?
for all such samples.
Sorry, what was it?
I guess I misunderstood the question. I thought it said saying what is the standard deviation for all such samples, and standard deviation isn't always going to be the same.
Wasn't it asking for a specific number?
I don't know. I gave more of a definition than a.
That's number D, right?
Yeah, 8B.
Standard deviation. Question 8. I think we have to calculate.
Okay.
To find the standard deviation, we have standard deviation divided by square root of the number.
Right, and then that formula. You do 113 divided by the square root of 10. And it gets you 35.734.
Yeah, I got that.
Yeah, that's what I got.
Yep.
Okay, cool. Should we move on to the group quiz?
Yeah, I think so.
All right. Just let me know when y'all have that loaded up. Obviously, the first 2 questions are just if you did the thing and participated.
Hey, wasn't the TA supposed to join us again?
I think so. But
Fail on his side.
I guess every night he thinks about joining us at 6:30, he decides not to.
Yes.
Well, just about every day I decide not to too, so I guess I can't blame it.
No, I literally set an alarm for 6:20. So
Yeah, me too. All right, when you're taking a sample size of blank of 5.
what does the shape of the distribution means?
When it's right skewed.
Do we enter that into the sampling distribution simulation thing, or?
Yeah, I'm doing it right now. It still gives you a pretty decent bell curve, actually.
Make sure I'm doing that right. I kind of highlighted the right side more for the parent population. Is that right?
Yeah, with the parent population, I just did skewed to the right. So under clear lower 3, I just went to skewed, and then it was on the right, skewed, and then, but the distribution of means is still a normal bell curve.
How do you make it skewed to the right and not skewed to the left?
You individually move the things, I guess.
Oh, so it's just higher on the right side?
Yeah,
Then you just do like 10,000 for the animation?
that's what I did.
So it shows up. Looks like a pretty decent bell curve still.
Yeah, it's normal,
So
whatever reason. When you're taking a sample size of N100, what is the shape of the distribution?
okay, so
Means.
n equals. Can you even do n equals 100?
Doesn't look like it.
Huh. Is there a way we should just know what it should be based off that it's a higher number?
Yeah, it should. It should be normal. If anything, it should make it more normal. Well, it'll start following closer to the parent population mean, but it should still be normal. 100 is not a big enough.
Yeah, I did 25 and it looks even more normal actually with a sample size of 10,000.
Yeah. I'm going to guess it's going to be even more normal. I guess we'll see if we get it right.
You're taking the sample size of n equals 5. What is the shape of the distribution means histogram when the parent population is normally distributed? Okay. Did Rachel fall off the chat?
Rachel, you there? Looks like it.
She just messaged me question 6 normal, I think. So, for the record, Rachel got disconnected.
But was here and is still contributing.
I don't know if the teacher actually watches every hour video, but if you do, bless your heart.
Yeah.
Yeah, I'm back again. Sorry for that.
Oh no, you're fine. We are in question.
Yeah.
Where should we on?
We're in question 5.
Yeah.
So if it's normally distributed, what does it look like? It still looks normal, right?
Yeah, I think normal.
Yeah. Still looks normal.
Yeah.
Okay. You're taking sample size of n equals 100. What is the shape? This one might be a little bit more tricky.
You want number
The
8?
sample size is big, is large, so it's normal. Yeah.
Yeah, it's normal. If anything,
For number 6 as well?
Yeah.
Yeah.
It's almost a perfect bell. What would the distribution? When would the distribution of means be normally distributed?
Mhm.
I think out of question 7, the first 3 are going to be right. I'm not sure.
Why not the last one?
I'm not sure about it. The more you get it under the law of large numbers, the more the simulation is run, the bigger it is, then the more similar to the parent distribution it is.
Yeah.
So if it's a large sample and it's right skewed, it should start to skew to the right. I just don't know if it does under 100 on the earlier question.
So we put down normal on the earlier question. That's all.
Yeah.
I was wondering if it would.
Problem is that I can't figure it out more than what they give us. I know I have right skewed. I run the sample 10,000 times
Mhm.
at a mean of 25, but I can't go up to 100. And
Yeah.
it's normal at 25, so I imagine it would be normal at 100, but I can't really say for sure. Kind of a pain in the butt.
Yeah, I don't see anything that would show us. If there's anything in the homework. Because the law of numbers states that if the sample size is large, then the sample mean will typically be close to the population mean.
Yes.
Yeah.
If the parent population is normal, the distribution of the sample of X will be normal for every sample size. Even if the parent population is not normal,
Then the sample distribution will be approximately normally distributed if the sample size is large enough. So I think,
it's always going to be normal then. Basically, right?
yeah.
So would it just be all?
The last one is not true because it's going to be right skewed.
I don't remember reading anything about like if there's a number large that it's going to be right skewed or something.
Yeah, they're all right.
Okay. Explanation essential limit theorem. Is it A? Or is it C? I think it's C. Well,
Yeah.
wait, if the sample actually it might be D. If the sample size is large, it would be approximately normal. I get, as it says in the book, don't get central limit theorem and law of large numbers mixed up, but it's hard not to.
I'm going to go with B on that one, actually.
The sample means are normal, then X is normally distributed. Yeah, I think it's D.
It's D. C is the law of large numbers.
Okay. Let X be random variable with a population mean of 10 for number 9. So is 9 just simply 10?
I think so. Excuse me.
So I think 10 is when you do the standard deviation divided by the square root of 36, which I get as 1. Does that sound right?
The 1.67. You're supposed to round that at all?
But you got 1.67 for 10?
Yeah, square root of 36 is 6. 10 divided by 6 is 1.666666, whatever. It's
Wait,
1.67.
do you divide it by the mean or by the standard deviation?
You divide it by the square root of the sample size.
Right, the top number would be the standard deviation, right?
Oh, you're right. I was doing that wrong. You're right. It's just 1. Nice catch.
Yeah, no problem. Regardless of the distribution, the population, if the sample size is large, what would be the shape? It would just be normal, right?
Should be.
I mean, we've put normal for everything. I guess we'll find out if we're missing something there. Okay, Rachel got 1 for 10 as well. 12, which theorem would you just for your response for the last question? Sample size is large.
Central limit.
That would be the law of large numbers.
Could be both. That's the hard part. So close. So the central limit is that x will be approximately normal. Large number says the sample mean will be close to the population mean. I'm going to say it's the central limit theorem, actually. Because the question above it says, regardless of the distribution of the population, what's the shape going to be? And a lot of large numbers bases it off of the parent population.
All right, I'll go with that too then. Guess we'll find out too. We get another try.
Yeah, we'll find out soon enough.
All right, I'll submit it then.
Looks like I missed one. Well, I missed a point on number half a point, a quarter of a point on number 7. Dang. And we missed number 3.
And you missed number 3.
Yeah.
I changed number 3 to skewed left, and it got it wrong, so then the answer would be skewed right.
Yep. I guess
I
that
don't
makes
know.
Parent population is right skewed. It's also going to be right skewed because the sample size is not large.
So 3 would be skewed left. I mean,
right.
Skewed right. Oh, so it would match its parent. I guess that makes sense.
Yeah, unless it's a large number, it'll match its parent size. All right, number 7, I got part of that right, but
I changed the last one to nothing, and I got 0.5 right, so D is right.
so D is right. C is wrong. That's why we got number 3 wrong. C follows our logic for number 3. It's right skewed.
Okay, let me get the quiz back up so I can take it again. So all of them are right, but C.
So
I mean, we're pretty much on the right track for the most part, saying most of them are normal now, so that's good. Because
yeah,
if they were,
we had that one hiccup. I got them all right this time. We had that one hiccup, but it's good to learn, I guess.
yeah. Let me just make sure D 10 1. My problem is retention of this stuff. Like, I feel like lessons like a week or 2 ago, I completely like out of my mind right now.
Yeah. No, I agree. I'm having a hard time balancing the equations in this and my accounting class.
I'm right there with you because I'm taking accounting as well.
Yep.
That's not like complicated math. It's just amount, organizing it.
Yeah. Cool. Well, thanks everybody for coming, I guess.
No problem. We'll see you Thursday.
Yep, I'll get this posted on there. Thank
Sweet.
you, Rachel.
We'll see y'all later.
Yep.